Welcome back to the Deep Dive. Today we're looking at, well, a foundation of all cloud computing. It's something that sounds completely straightforward storage, but in reality it's probably the single most common source of cost overruns and performance bottlenecks if you get it wrong.
It really is. It's the truth behind the curtain. I mean, if compute is the fast-thinking brain of your cloud architecture, then storage is the memory.
That's a great way to put it.
It's where every bit and byte of your application lives, and if you match the data type to the wrong storage, your system it won't work efficiently.
And our sources today give us a spectacular roadmap for this, specifically within the AWS ecosystem. They really stress that the big mistake people make is treating all memory the same.
They do.
So our mission today is to unpack the three main flavors of cloud storage: block, object, and file.
And you really can't overstate how necessary that is. The source material uses this great analogy. It says choosing the wrong storage is like trying to eat soup with a fork.
Right, you have to match the tool to the task.
Exactly. We're going to dive into the architecture of each one so you know exactly which tool to grab.
Perfect. Let's start with flavor number one then, block storage.
Okay.
This is conceptually the easiest one to grasp, I think, because it operates a lot like a traditional hard drive that we've all used. So how is it engineered?
Well, the name says it all, really. The data is broken down into these small, discrete, uniformly sized chunks. They're called blocks.
Oh, yeah.
And crucially, these blocks are all addressed individually. So think of it like a huge digital filing cabinet where every single piece of paper has its own unique address.
And the power of having that granular addressing is what?
Efficiency, especially for transactional processes. So if you're running, say, a high-speed database and you need to change one character in a record.
Just one tiny change.
Just one. The computer doesn't have to read and rewrite the entire file. It just finds that one single tiny block, updates it, and saves it. That's what enables those extremely fast, granular edits.
So in AWS, this block storage idea comes to life in two very different products.
Right. And the distinction here is absolutely critical.
We have Instant Store and Amazon EBS, which is Elastic Block Store. Let's start with the one that causes the most trouble, Instant Store.
Yeah, this is where we really need you to focus because Instant Store is a performance monster.
But
it has a lethal caveat. It is physically attached to the host computer, the actual hardware running your EC2 virtual machine.
which means it's fast.
Blazing fast. There's no network latency involved.
Okay, sounds great. But if EBS is network attached, how big is that speed trade-off? And why would I ever risk using Instant Store if the downside is so severe?
Well, the speed is noticeable for sure, especially for high I/O applications like temporary caching or message queues where every millisecond counts. But the trade-off is, like you said, a severe risk.
Because it's ephemeral.
It's ephemeral,
Yep.
temporary. The data is not persistent.
So explain that danger zone for us.
If your EC2 instance is stopped or rebooted or terminated, or even if the underlying physical hardware fails, the data on the Instant Store is permanently deleted. It's volatile. Goof. Gone. We've seen companies face huge downtime because they mistakenly put a critical log processor or something on an Instant Store, and it just vanished during routine maintenance.
So the key is the data has to be 100% disposable, something you don't mind losing.
Precisely. If you care about keeping it, you have to use the second option, Amazon EBS.
The persistent flavor.
That's the one.
So how is EBS engineered differently to make sure the data sticks around even when a server fails?
EBS volumes are networked storage. The best analogy is an external USB hard drive. But instead of a physical port, it's connected over a network cable inside the same data center.
Ah, so the storage is independent of the computer.
Exactly. If you stop the computer, the EC2 instance, the data is completely safe on that EBS volume. It's ready to be reattached to a different computer. That independence is persistence in the cloud.
That is the critical distinction. Data that needs to outlive the server needs EBS. Now, our sources also mention backups here, EBS snapshots, and they say they're efficient because they're incremental. What does that actually mean for you, the user?
So snapshots are basically backups of your EBS volume, and they're stored in S3, but incremental is the magic word.
Okay.
Imagine you have a massive 1 terabyte database volume. Between Monday and Tuesday, you only update, say, 5 kilobytes of data.
A tiny fresh?
Tiny. If the backup process was a full backup, it'd have to send that whole terabyte over the network every single time. But because it's incremental, it only saves and transfers those 5 kilobytes of changed blocks.
So the efficiency isn't just in storage cost, it's It's also the network bandwidth and the time it takes.
Exactly, which for massive volumes is huge. It dramatically reduces your backup window and your operational costs.
Okay, so we've sorted out persistence and transactional data with block storage. But what about the other massive problem? Scale. What if I need to store petabytes of data for years? Files that never change, like videos or archives.
Well, that brings us right to flavor number 2, object storage. And the most famous cloud service out there, Amazon S3.
The simple storage service.
Right, and the first thing you have to do when you think about S3 is just throw the hard drive analogy out the window. It is not a hard drive.
It's a warehouse.
It's a virtually infinite warehouse.
So what defines this warehouse compared to the block storage we just talked about?
The key difference is immutability. With block storage, we could dive in and edit a single character. With object storage, the data, whether it's a huge video file or a tiny text doc, is treated as one whole distinct, immutable object.
And you store it in a container called a bucket.
Yep, in a bucket.
So if I upload a photo to S3 and I realize I need to crop it, I can't just open it and save the change.
No, you have to download the original, make the edit on your machine, and then upload an entirely new version of that object.
Which is why it's perfect for static things.
Perfect for static, non-changing items like video archives, machine learning data sets, massive backups. And of course, the main feature is that scale. It's virtually unlimited.
Unlimited scale sounds expensive.
Yeah.
I know S3 isn't just one price tag, so where's the trick to optimizing it? We hear about standard infrequent access, Glacier.
And that's it right there. The complexity of all the S3 classes is purely about cost management. It's tied directly to your access frequency.
And this is where you, the listener, can save a ton of money.
An enormous amount of money by matching the value of the data to its cost tier.
Okay, let's break those tiers down.
So S3 Standard is your premium tier. This is for hot data files you're accessing multiple times a day or a week. You get millisecond access, and because it's so fast, it costs the most per gigabyte to store.
Then we start moving down to save money.
Next is S3 Standard IA for infrequent access. This is the sweet spot for data you might only access, say, once a month.
So the storage cost drops.
It drops significantly, but there's a trade-off. You pay a small retrieval fee every time you access the data, so it encourages you to only pull it when you really need it.
And then there's the deep freeze, Glacier. I know there are a few Glacier options now, but let's just stick to the main one. Why is it so cheap? And why does it take hours to get your data back?
It's cheap because the infrastructure is optimized for durability and low power, not speed. I mean, think of it like a tape backup system in a highly secure, temperature-controlled vault.
Okay.
Someone, or some robot arm, has to physically go find it. The resources are just slower to access. It is strictly for archival, historical tax records, compliance backups, things where retrieval in hours is totally fine.
And what's fascinating here is that you don't have to manage all this manually. You can automate it.
That is the crucial nugget. S3 lifecycle policies. This is where you configure automatic rules right in the AWS console.
So you could set a policy that says, what?
For example, you could say, if this object hasn't been touched for 30 days, automatically move it from standard to infrequent access. And if it stays untouched for 365 days, transition it to Glacier. It automatically saves you massive amounts of money, no human intervention needed.
You just set the rules based on how you expect the data to be used, and the system does the rest.
It completely changes the game for data retention. It connects the technical idea of storage classes directly to the financial reality of running an application at scale.
Okay. We've got transactional persistence with block, and we have unlimited cost-optimized scale with object. That brings us to our third and final flavor, file storage. Primarily Amazon EFS.
The elastic file system.
And I have to ask, why does this exist?
Right.
I mean, if EBS is a hard drive, how is EFS different enough to be its own thing?
The core distinction is one word, sharing. Go back to our analogy. EBS block storage is that loyal dog. It is dedicated to one master one EC2 instance at a time.
Right.
If you try to attach a second computer to that EBS volume at the same time, you risk file corruption, system failure. It's only designed for single host control.
So if I have 100 servers running my app, and they all need to see the exact same config file at the exact same time, EBS can't do that.
It cannot. And that's where EFS comes in. EFS is the free spirit. It lets hundreds, even thousands, of EC2 instances attached to the exact same file system simultaneously.
So they can all read and write at the same time.
All reading and writing in a coordinated way. It's the shared folder from traditional networking, just built for cloud scale.
So for a big web application with a fleet of servers, They all need access to a shared directory for, say, session state or user uploads. EFS solves that.
That is the primary use case. It removes the need to copy files to every single server. It ensures consistency across your entire fleet.
And the sources say EFS is for Linux, right? Built on NFS.
That's right. It's native to Linux if you're in a Windows environment and you need that same shared access.
What's the option there?
And you'd look at Amazon FSx for a Windows file server. It's the same principle of shared access, but it uses the SMB protocol for Windows.
Fantastic. Okay, we've defined the three flavors: block for persistence, object for scale, file for sharing. Let's shift gears now to an application deep dive.
Okay, let's do it.
We'll run through three classic scenarios. But instead of just naming the answer, let's talk about the consequences of choosing wrong.
Let's focus on the pain points. Good idea.
Scenario 1. You're running a sophisticated transactional database. Thousands of operations per second, constant granular updates. Speed and persistence are key. What are you using?
That has to be block storage, specifically Amazon EBS.
And why not the others?
Well, object storage would force you to rewrite the entire database file for every single record change. Performance-wise, that's impossible, and file storage would just be too slow and add complexity you don't need for a dedicated drive.
Right. Scenario 2. You're building a Netflix competitor. You need unlimited capacity for millions of huge, unchanging video files, and you need robust long-term archiving.
Textbook object storage, Amazon S3. The unlimited scale is non-negotiable.
And the failure condition. What if you tried to put those millions of videos on EBS volumes?
Oh, you'd need hundreds of volumes. You'd be hitting scale limits constantly, and you'd be paying top-tier prices for data that just sits there untouched. You'd bankrupt the project.
The S3 cost tiers are the only thing that makes that financially possible.
It's the only feasible model for that scale.
Okay, last one. Scenario 3. A fleet of 50 data analysis servers are all processing raw satellite imagery. They need to access input data from a central folder and write results to a common shared output directory.
Shared read-write access for a fleet of servers. That screams file storage, Amazon EFS.
And the consequence of failure, if you tried this on a single EBS volume?
It wouldn't work. You'd attach it to one server, and the other 49 would just be sitting there, unable to access the data. Your entire analysis workflow would grind to a halt. EFS is the only way to get that coordinated collaboration.
That really drives it home. You have to match the access pattern to the storage type. Now, let's revisit that trickiest trap we talked about.
The ephemeral trap.
Yes. You launch an EC2 instance, and the OS gets mistakenly installed on an instance store root volume. You stop the instance to do an upgrade, then you start it again. Yeah. What happens?
The pain is immediate, and it's total.
The data is
wiped clean. Because instance store is ephemeral, stopping the instance triggers deletion, the operating system, your configs, everything is just gone.
A painful but necessary reminder: never use instance store for persistent data. The speed gain isn't worth that cost.
Not unless you are 100% sure you don't need the data to survive a restart. EBS persistence is the default for a reason.
Okay, one last thing before we wrap up. We need to bridge the physical world to the cloud world.
Ah, yes, the storage gateway.
Our sources call it the hybrid cloud bridge. What is that exactly?
Storage gateway is software you install in your physical office in your data center. It acts as an interface that connects your local network, your users' desktops, to the infinite scale of AWS S3.
So my employees can save files locally.
Right, which gives them local access speed.
But data is actually being stored in S3.
Exactly. It's automatically and durably replicated to S3 behind the scenes. So you get to decommission your old, expensive on-prem storage, but the process is totally invisible and fast for your users.
It's the essential tool for migrating off legacy hardware without a huge disruption.
Precisely. It enables that hybrid cloud solution. Speed of local, durability, and scale of S3.
So when we zoom out, what does this all mean? We have block for dedicated transactional persistence. We have object for unlimited scale and cost-optimized archiving, and file for simultaneous shared access.
And the final takeaway for you is that the choice is dictated entirely by the access patterns of your data. Don't choose based on file size or even cost at first.
Choose based on how it's used.
Choose based on how frequently the data changes and how many servers need to touch it at the same time.
And we spent a lot of time on the financial impact of those S3 lifecycle policies, automating the movement of data from expensive hot tiers to super cheap archives.
Which really raises an important question for you to think about going forward. When you launch a new project, how often are you truly analyzing the difference between data that's need it now, hot,
Right.
versus data that's needed maybe once a year, archive material, the financial implications of getting that right, of automating that data tiering, they're absolutely huge over the life of a project. That one decision can save or cost millions.
That's a fantastic insight to end on, connecting the technical choice directly to the bottom line.
Right.
So we've successfully stored our data.
We have.
Next time, we're moving on to the flip side, monitoring and analytics, finding out exactly how all these cloud resources are performing in real time.
See you then.